Which of the following addressing method does the instruction move A, B represent? See, first of all, there are different kind of addressing method. Addressing method is nothing but where the data will be, whether it is available right there or in the register or in the memory. So this is the addressing mode. So the answer here is register indirect addressing mode. In the register indirect addressing mode, the address of the operand, that is on which the opcode is going to operate, is stored in the register. And since the instruction specifies that the register used to refer to the address is accessed indirectly, that is why it represents the register indirect addressing mode. So we have register indirect addressing mode also and direct addressing mode also, which you see as the option B. So let us just see here. This is the opcode. This is the indirect addressing mode. That is, you won't have the data right. You will have the address of the data. In 8-bit microprocessor, how many opcodes are present? Opcodes, that is, this is coming from the instruction. Instruction is coming from the instruction set. Every microprocessor has certain instruction set. Okay. So in 8-bit microprocessor, we have how many? See, 8 means 2 to the power 8 is the highest limit. But here we have 256. Every operation has two parts, an opcode part and the second part, which is the operand part. For example, move A, B. So first part is the instruction and second part is the data. In an 8-bit microprocessor, maximum 2 raise 8, which is 256 opcodes, these are possible. But it consists only of 246 opcodes. Which of the following is the correct sequence of operations in a microprocessor? So whenever there is an instruction contains of the, for example, we have LDA, certain operation. So there will be certain fetching and there will be some storage and reading and writing. So what is the process? It means correct sequence. So fetch will be done, decoding will be done, then the execution and the storage. This is the whole instruction cycle which is being followed for any kind of instruction. So what is the correct sequence of operation? We have three. First of all, because first thing is opcode, then operand comes. So opcode fetch will be done. Then the memory read and memory write will be done. And then the input output read and input output write will be done. So this is the correct sequence of operation in a microprocessor. The die directive instructs the assembler to begin memory allocation for a segment block code from the stated address. So in order to begin this memory allocation, ORG will do. ORG, you can say a short form of origin. The answer is C here. So ORG means origin. ORG is used for specific addressing in microprocessor and the microcontroller programming. Let us take an example. The location counter is actually initialized to 00H. For example, if ORG 0000H is there, this means we want to start our program from this address 0000H. So whenever the ORG we write, the assembler starts the location counter to keep track of the modules allocated or allotted address as possible. Specified in the directive, which is ORG. ORG is all about starting that origin. What does a microprocessor understand after decoding opcode, operation code? So any operation has two parts. The parts are opcode and operand. Opcode also has inside it, means the microprocessor understand that what is the addressing mode and what data it is going to act, how the data will be accessed is the addressing mode, and the data will be called as operand. Okay. Now the question is, what does a microprocessor understand after decoding the operation code? So for example, we have LDA, add, move, all these are instructions. So to decode this opcode, what do we get? So after decoding the operation code of the instruction, a microprocessor understands the length of the instruction, 1 byte, 2 byte, 3 byte, and the total number of operations to be performed, because there are different T state in instruction cycle. There is memory write, memory read, fetch, all these are done. So the answer here for this particular question, what does a microprocessor understand, is C, length of the instruction and the number of operations. After decoding the operation code opcode. Which of the following register is not used in opcode fetch operations? Not used in opcode fetch operation. Okay. See. So any instruction will have two parts. The operation code opcode and the operand. Opcode and operand. So which of the following register is not used in opcode fetch operation? So flag register, this is not used in opcode fetch operation, because this flag register is used to represent the, for example, some operation LDA is there. So this is used to represent the status of arithmetic and logic operation which is performed after decoding the opcode. Once the opcode is decoded, then it is done. Okay, for fetching operation, flag won't be used. Once all things are done, then some operation is performed, then all the flags will be affected, otherwise, or they are used. Otherwise, fetching the opcode won't, though this program counter, the memory address register and memory data register, all these three, they will be the part of fetch operation, not the flag register. Okay. Which of the following is true? Which is true? So let us see which are false. Every instruction has two parts, opcode and operand. We know that opcode it by itself is having the idea about the addressing mode. Addressing mode is all about the data to be found out. Data is called as operand. Opcode is the operation to be performed. So first one is true. That means the others have to be false. See, move BC is 2-byte instruction because there is no data present. It is just B, C. It is a 1-byte instruction. Since in MVI we have 98, that is one data is present. So it is a 2-byte instruction. So the B is incorrect because it is given 2-byte, but it is actually 1-byte. MVI is 3-byte given, but it is actually 2-byte. Right? And maximum number of T states possible for the execution of an instruction is 16. See, the T state, most of the T state is taken by call. So if you see call, there are multiple things happening. 6 T states for operation fetch and memory write, then 2 for the pushing onto the stack. Then we have memory read, again for new value of PC fetch from memory. If you combine them, there are 18 T state for call operation. So it is 16 given. So that is why it is wrong. Which of the following is true about move A, B instruction? Okay. See, move, what all is there? First, let me tell you one by one. First is, it doesn't affect the flag register. This is your answer. It doesn't affect the flag register. Because move is doing what? If you have a location, one source, one destination, from source it goes to the destination. The content is only copied. It is only copied. So there will be no change in the flag register. It is not a 2-byte instruction, but it is because move is 1-byte instruction. It means move the content of register A to B. No, it means moving the content from register B to A, not A to B. That is why this is also wrong. It uses immediate addressing mode. No, it uses the register addressing mode. So the only answer is C. All others are incorrect. Which of the following is false about LDA instruction? See, LDA is load accumulator direct. Load accumulator direct. Right? So this is the full form. Now this is a direct addressing mode instruction. So it uses indirect addressing mode. That is going to be false. Because LDA is a direct addressing mode, because after that the address is directly given in the instruction. LDA 2000H, so 2000 is already given. It is direct addressing mode. And then it is actually 3-byte instruction. That is correct. It has or it uses 13 T states. That is also correct. And it doesn't affect any flags. That is also very true. So only the false option is it uses indirect, because it actually uses the direct addressing mode. Right? Load accumulator direct means you are loading accumulator directly to this. Wherever this address is pointing, the data on this address will be loaded to the accumulator. Which of the following is true about STA instruction? So STA instruction is store accumulator direct. The answer is it is a 3-byte instruction. Store accumulator direct. It is a 3-byte instruction. That is correct. Now what all are incorrect? It uses immediate addressing mode. No, it uses direct addressing mode because the address is directly given after STA. 3-byte, yes. It requires 3 machine cycles. No, it uses 4 machine cycles. Accumulator is loaded with the content of memory. No. And ST instruction memory is loaded with the content of the accumulator, not the content of the memory. Okay. So this is also incorrect because STA instruction memory is loaded with the content of the accumulator. DAA instruction is used to perform which type of addition? The DAA is simply decimal adjust accumulator. So the answer here is it's A, BCD addition. This DAA instruction is used to perform the binary coded decimal addition, and the DAA instruction changes the binary values of the contents of the accumulator to what? To the binary coded decimal. You see also in the example, I've tried to show it. Okay, you can just go through it. But the answer here is A, BCD addition. Suppose registers A and B contains 50H and 40H respectively. After instruction move AB, what will be the contents of register A and B? The move is what? A, comma B. So the content of B will be transferred to the content of A from source to destination. But the A will have the content of B, but B won't change. B, until you replace it, if A is having 50, B is having 40, when you transfer, when you move, now A will have 40, B will itself have 40 because it was having 40 until it is not being replaced. So the answer will be 40, 40. So that will be A. So A and B both will contain 40, 40H. Which of the following is not correct about halt instruction? Now the name itself is halt. That is stopping. It is already saying stop. So the answer, what is the answer? Not correct about halt. What is not correct? The answer is B. It is used to start the execution of the program. Actually, it is not correct because halt means stopping. Halt is a machine control statement. Internally, what is being done is the PC is disconnected from the address bus, for example, so the next fetch won't be possible. So it is used mainly to stop the execution of the program. Okay. So it does not affect the content of the register and flags. Once the processor is halted, it can be brought to the normal mode only by the resetting the processor. So halt is used as a last instruction in every assembly language program. Halt, the instruction stops the processor. Okay. So the 8085 repeats the fetch, decode, execution cycle until it is deliberately stopped, which is done by halt. HLT is the option. Which of the following is a two-word instruction set? Two-word instruction set. Answer is C. IN01H. The first one LDA 2500H and these JMP 2085 because the direct address is given. It is a 3-word instruction. All the memory address is given. That is why it is a 3-word instruction. Move AB is a 1-word instruction. Though there is no data, only A and B is given. So IN01H, this is a 2-word instruction. What is this? This, the first byte, is specifying the opcode which is IN here. And the second byte, which is 01, it will specify the operand. Which of the following is true about SPHL instruction? Now SPHL, SP is for stack pointer, HL is for HL general purpose register. The answer is content of HL pair is moved to SP. Now if you remember B, C, D, E, HL, there were these register pairs we talked about. So SPHL is basically a 1-byte instruction. It uses register addressing mode. It is using register addressing mode. It requires 6 T states and it is a 3-byte, no, it is 1 byte, and 6 key states it use. It means moving the contents of HL pair to the SP, that is the stack pointer. HL to stack pointer.